Hey Calculus Kids, this is Dr. Callahan with Week 7 Friday. Congrats, you guys made it to the end. Go ahead and pause the video and answer the following 3 questions for your warm-up for Week 7 Friday. Keep in mind that your warm-up log is going to be due on Week 9 of Friday, so in 2 short weeks, you will have 300 points added to your grade. I will highly recommend that if you have any of the boxes that's empty, that you go to MS Team, take a look at the videos. You have all of them from Week 1 Monday to Week 9 Friday, or you will anyways. And so take a look at that and make sure you watch the beginning so you get all 3 questions filled out. Let's go ahead and get the assignment going. So this is Week 7, Friday, AP Calculus, AB Semester 2. Make sure you guys watch the video today and check in with me by second period, which is 9:41 a.m. That's the end. I would have to take attendance prior to that, so make sure you check in with me at the latest 9:41 for Friday. And then today our topic of discussion is going to be on differentiation of trig inverse. Okay, so I'm going to go ahead and type this in right here. I thought yesterday when we talked about integrals of trig inverse, it was pretty simple for the most part. I think the differentiation is definitely more difficult than the integral part of that. Your assignment needs to be uploaded by 3 p.m., so just keep that in mind. And this is not in problem stats. Ooh, crap. Let me see if I can maybe just get rid of that. Clear. Clear, clear. No, dang it. Okay, let's see if I can put it in calculus. Well, that's just stupid. You can't even go ahead and cancel that class, but that's okay. I'll just go ahead and hit assign and hopefully that'll pop up. But deep down, I'm hoping that I can delete this because obviously I don't want this to be popping up here. Let's see. Give me a second. Let me make sure that it is done correctly. Okay, but I don't see it. I don't see the assignment here. It popped up and it said it was here, but it's not here. That's okay. I'll give it a minute, and then if it doesn't show up, we'll try to figure it out again. Anyways, we'll go back to this. All right, so let's go ahead and take a look. Okay, on your desk, I want you guys to write integral and then write derivative. And I want you to tell me if you know what is the arc sine, arc cosine, arc tangent, and the derivative formula for this. Do the same thing on the, integral formula. Do the same thing with the derivative formula for arc sine, arc cosine, arc tangent. And then I want you to go ahead and draw me the unit circle right here. So pause the video and write this down somewhere, either on the guided note packet that you have. I'm sure there's going to be one empty page there somewhere in the very back. Or you can go ahead and do this on a separate piece of paper. All right, let's go ahead and take a look. So take a look at where you are. Make sure you're able to go ahead and memorize them, because you are required to memorize this because they're not going to give it to you on a formula sheet. So you don't want to memorize this like literally, the night before. All right. This past week, we covered the following: derivatives of inverse trig functions and integral inverse trig functions. Today, we need to do all of this with product and quotient rule. So it's going to be kind of like a combination of several things all together. Okay, so let's go ahead and take a look at this. This is find the derivative of the arc sine. So as you can see here, it looks like I'm gonna have to use the quotient rule somehow with this one. So I'm just gonna go ahead and let's go ahead and say, let's let f be the numerator, arc sine x, or 3x, sorry. And then f prime, now remember your arc sine is going to be, and let's just do it over here. The derivative of arc sine u is equal to u prime over the square root of 1 minus u squared. All right, so then before I can even find the derivative of f prime, I will have to say let u be 3x. du is going to be 3 dx. dx equals du over 3. So here I need to have u prime, and I do have u prime. U prime is 3. I will need to have u squared. U squared is 3x squared, which is 9x squared. So now that I have these two components, let's go ahead and just substitute it in. So f prime equals u prime. U prime is 3 over square root of 1 minus u squared, which is 9x squared. All right, so at this point here, you have your f prime. Now let's go ahead and focus in on g. G is a denominator, g prime is just 1. Well, that was simple enough. All right, so then let's go ahead and plug this in. You know that with the quotient rule, it's f prime times g minus f times g prime over g squared. So then here we go. F prime times g is just going to give you a 3x over the square 1 minus 9x squared minus f times g prime. So here's f times g prime, which is going to give you arc sine 3x times 1 is just arc sine 3x. All the way over g squared. G squared, which I did not get to, is going to be x squared. All right, so I see that there's a fraction on top of a fraction. So I want this to be a square root of 1 minus 9x squared, which means I will have to multiply here in the numerator as well. So then if I want to go ahead and rewrite this, I will go ahead and have 3x minus arc sine 3x square root of 1 minus 9x squared all the way over square root of 1 minus 9x squared. And then with your denominator here, all you're going to do is remember you're going to put divided by x squared, which is the same thing as saying times by 1 over x squared. So that x squared is really just going to be on the bottom. And that's it. This is your answer. Pretty elegant, pretty simple, nothing too crazy overall. All right, you guys, let's go ahead and move on to today's stuff. So today, you have your guided notes right here. This is going to be on the integrals of differentiation, so second day. So I would like you guys to go ahead and get started with this page right here. And let's make sure we know the integrals of this, okay? All right, let's start with the very beginning. Integral of du square root of a squared minus u squared is going to be the same thing as arc sine u over a plus c. Now see if you know how to do the second and third one. Second one is 1 over a arc tangent u over a plus c. And the third one is 1 over a arc secant absolute value of u over a plus c. Okay, now let's go over some of the examples here. First one is pretty simple, so I'm actually just going to give you guys the answer. Arc sine x over 2 plus c. That is your answer for the first one. So easy peasy. Let's go over the second one, okay? With the second, remember, you want to have the denominator look like either 1, 2, or 3. I think it's probably going to be the second one, mainly because there's a plus sign. So I'm thinking that's kind of what I'm going to aim to make it look like. So let's go ahead and match it up. Remember your a squared plus u squared. Your u obviously is with a variable. So then from here, I can say that my a is going to be a square root of 2. My u is going to be a 3x. My du is just a 3dx. And my dx is equal to du over 3. Okay, so let's rewrite this. Here's the integral. Here's the 4. Here, I'm going to have an a squared plus a u squared. Change my dx with a du over 3. Now, I know that the integral of this is equal to 1 over a, which is the square root of 2, arc, tangent, u, which is a 3x, over a, which is the square root of 2, plus c. But then you have to be very careful with this because you don't want to forget your 4 and a 3. So I'm going to put a 4 here and a 3 right there. And this is your answer. It's not very elegant, but it is the answer, and that's it. And part of my answer disappeared. So let's put that back. There we go. All right, let's go ahead and take a look at example 3. You can pause the video and try this one on your own. And when you're ready, you can unpause the video and we'll go over it together. Okay, so first things first, I know that there's an x. So most likely, I'm probably going to be using this one here with the arc secant. Okay, so then let's go ahead and compare it. And then from there, you know your a is going to be 3, your u is 2x, your du is 2dx, and your dx equals du over 2. So from here, I'm going to have the integral. And I have a u square root u squared minus a squared. On top, change your dx to the du over 2, like that. And remember, this is equal to this entire piece right there, which is going to be 1 over a, that's 1 over 3, arc secant, absolute value of u, which is 2x, over a, that's 3, plus c. But don't forget your 2 right there, so then your 3 becomes a 6. Oh, you know what? Hold on a second. I did make a little typo here. Okay, and the typo here that I made here is with my x, do you see how u equals 2x? So I need everything in terms of u. So I need to solve that for u. So if u equals 2x, if I divide it by 2 on both sides, x equals u over 2. So there's a 2 right there. And so then if x equals 1 over 2 times u, then here I will have the integral of x, which is 1 over 2u, times, changing the dx is du over 2, times, and the bottom over here, I'm going to go ahead and change that u, or 4x squared, to a u squared minus a squared. So that at the very end, this right here is 1 over u, so that's going to be a 4. There you go. So it's 1/4 arcsecant, and this is your answer. Okay. So then let's take a look at some of the little more complicated ones on the bottom of your paper here. So with this one, we're going to go ahead and say, let u be e to the x. So your du derivative e to the x is just e to the x, dx. So then your dx equals du over e to the x. So let's rewrite this. Dx, change it to du over e to the x times square root of e to the 2x. E to the 2x is the same thing as e to the x times 2, right? So then e to the x is u, then you have a u squared minus 1. Okay, so then looking at this, which one does this look very familiar to? Which one does it match? I think it's the match the first one with the sign is what I think it'll match. Actually, no, just kidding. It's not. It looks like it, but you know what? I actually forgot that there was an e to the x right here. And what is e to the x? It is u. There we go. So now that I have a u on the outside, I would have to go ahead and use the third one right there. Okay, so now let's see if everything is matching here. U squared minus a squared, and we can say that a equals just 1. Okay, obviously because you could put a square right there. All right, so now that I have this ready and prepped up for this integration, I don't have any numbers here like constant that I need to bring back. I could just say that this is equal to 1 over a, so that's just 1 over 1, so really it's just 1. Arc, secant, absolute value of u is e to the x, over a, which is 1, plus c. And if you want to go ahead and make this look a little bit better, it's just arc secant e to the x plus c. And that is your answer. Okay, let's take a look at the next one over here. With this one, I see that this is my a squared minus u squared. So I'm thinking it's going to go into this one here. So let's see where it's going to end us. Let u be 4 minus x squared. Then your du is a negative 2x dx. Your dx is a du over negative 2x. My problem here that I see is that, okay, how am I going to cancel that with that? That's not going to be very easy. However, if I were to split this fraction, I would be able to cancel that x with this x here. So we're going to split the fraction. So I have the integral of x over square root of 4 minus x squared plus the integral of 2 over the square root of 4 minus x squared. And that's totally legit. It's fine. Okay, so then looking at this part right here, let's go ahead and rewrite this. Integral of x over, and remember there's a dx on both of these, square root of 4 minus x squared is going to be the square root of u. So square root of u. Change your dx with this part right here times du over negative 2x. If you look at this, see how the x cancels? Gone. So I have a negative 1/2 on the out. 1, or actually I could just move that u up to the negative 1/2 du. And that's fine because remember, if you're doing the integral, you're going to go ahead and do a plus 2 over 2, which is going to give you a positive 1/2. So you're going to divide it by a positive 1/2. But remember, you got to flip that. So then your first part of your answer is going to be a negative 1/2 times, flip it, 2/1 times u to the positive 1/2. Okay, so that's the first part of your answer. So just keep that in mind for the time being. And if you look at this, if you want to, that cancels. So it's a negative u. And what is u again? It is 4 minus x squared to the 1/2. So really it's minus square root of 4 minus x squared. So that's the first part of your answer. Okay, so just keep that there for the time being because you still need to tackle the second part of the answer, which is over here. Okay, so with this one, you could probably just use a direct integral substitution with an arc sign. I mean, from here, you know that your a equals 2, your u equals x, obviously. And so when you do the integration, you do have a 2 here times arc sine u, which is an x, over an a, which is a 2, plus c. So then let's go ahead and join these two together, and that'll be your answer if you just squish them together. All right, let's take a look at the last one. All right, with this one, we're going to have to split the fraction as well. So let's go ahead and split this. Partially, it's because I'm not even quite sure how we're going to do a u substitution. You won't be able to do this one here because you can't get rid of the x minus 2. So if I were to split this fraction, let's see, split. If I split this fraction, let's do x plus 1. Because if you think about this, if it's x minus 2, isn't that the same thing as x plus 1 minus 3 plus 1? Or I'm sorry, minus 3. Just kidding. Here we go. So, and the reason why I want to do that is because if I let u be this part here, if I do the derivative of this, it'll be 2x times x plus 1 to the 1 power times 1, which is a chain. I want to keep this part as x plus 1 in the numerator and the chance that I can cancel that later on. So that's kind of where my strategy falls in right now. So I'm going to split my fraction. And really, this will be a minus 3. Integral 1 over x plus 1 squared plus 4. Okay, so then I'm going to do my u sub over here with the first part of the integral with u. Let's let u be just x plus 1 squared plus 4. Then your du is 2x plus 1 to the 1 power times 1, which is a chain, and then 4 becomes a 0, dx. Okay, so then if I solve for dx, it would just be du over 2 times x plus 1. And the entire purpose of doing this is so I can cancel the numerator right there. Okay, so let's set this up. Integral x plus 1 over, don't forget your dx because there's a dx on both of these. You have u, which is right here, okay, times the dx, which is a du, over 2 times x plus 1. Well, your x plus 1 cancels, which is great because then you have a 1/2 integral 1 over u du. And then what is your integral of 1 over u? Well, you guessed it correctly. It's ln u. Your u is x plus 1 squared plus 4. And that's your first part of your integration. Okay, so I'm just going to leave it there for the time being. Then for my second part right over here, I can probably use this with one of the 3 formulas on top because I only have a 1 on top right there, and that's not going to mess me up because all of these have a 1 on top of that. So which one do you want to use? Which one matches? I think it's probably going to match the arctangent one. So with that, you know you have your a is going to be x plus 1. Your u is going to be 2, okay? And so, and your du is just going to be, wait, hold on a second. Sorry, my u is not 2. I don't know where I even got that. My a is, no, okay, my x, okay, I screwed this up. Hold on. My a is going to be 2, because remember your a is constant. My u is x plus 1. So your du is going to be just dx, okay? So then let's kind of rewrite this. 1 over this right here is going to be substitute as a u squared plus 2 squared. Change your dx to a du, okay? So then here, let's go ahead and rewrite it. 1 over, and just apply it to this part right here. 1 over a is 1 over 2. Arc tangent u, which is x plus 1, over a, which is a 2 plus c. So then there you have it. You have this piece right here. Oh, you know what I forgot? I kind of forgot to have this minus 3 right here. So minus 3. Don't forget your 3. This is our first piece, minus 3 over 2, arc tangent x plus 1 over 2 plus c. And this is your answer right there. All right, you guys, not everybody can do this. So if you are understanding this, that's pretty phenomenal. For the rest of the class, I would like you guys to go ahead and practice on this page with the following examples right over here on differentiation and also integrals. So what I would like you guys to do is practice with these textbook questions. If you have any questions, there's a link that will go over the videos with you guys. I have some extra practices right here as well, so you're welcome to do that. And as always, stay safe and healthy, and I'll see you guys next time. Take care.